question 3, we have to calculate the maximum kinetic energy of the hydrogen atom. And to do that, we're going to have to remember the formula for kinetic energy, which is half mv squared. And the mass we're given, because it's 1.7 times 10 to the negative 27. So it's the velocity that we're going to have to calculate. And because we want the maximum kinetic energy, we're going to want the maximum velocity. So V max. And I hope you remember that the formula for the velocity during simple harmonic motion is given by omega times x0 squared minus x squared, where x is the displacement and omega is the angular frequency. And the maximum value we're going to get when x squared, so when the displacement is 0. So this whole thing goes. And now we can take the square root of the amplitude squared, which is going to give us omega x0. So we're going to have to find our value for angular velocity, sorry, for angular frequency, and our value for the amplitude, and multiply them together. So if we go back to question 1, the amplitude was this, and the angular frequency was this. So let's just write them out here. So we've got 5.65 times 10 to the 14 radians per second, and then we're multiplying that by the amplitude minus. Okay, and we'll bring a calculator out, and I still have my value for the angular frequency on here, so we can multiply that by the amplitude, which is 1.5 times 10 to the negative 10. Okay, and it gives us this number. So this is going to be the maximum velocity. So if I put that to the side, you can write down that the maximum velocity is going to be 848, and I'll round it to this for now, but I'll keep the full value in the calculator. Okay, so now let's put that into the kinetic energy. So it's going to be half, so I'll write 0.5, and then the mass of the hydrogen atom, which is this, and then the velocity is squared, so we've got 84800 squared. And let's put all of this into the calculator. I already have my velocity in here, so I'm going to square it first thing, and then we just have to multiply it by 0.5, and then the mass of the hydrogen atom, which is going to be that, and press enter. So this is the number I get, 6.12 times 10 to the power of negative 18. So if we round that to 3 significant figures, 6.12 times 10 to the power of negative 18, and the unit for energy, and we used SI units for everything here, so the unit is going to be joules. So that's the maximum kinetic energy we get